In this module, we are going to observe energy consumption of various programs. This exercise is intended to be performed using the supplied Docker image. We will observe energy consumption of NAS parallel benchmarks. They consist of several benchmarks solving various problems. Each benchmark has a set of different variants, called benchmark classes, depending on the size of the problem. Let's try executing these benchmarks. They are available as programs inside the container, and for instance FT, that is the Fourier transform, has 7 classes. When executing a benchmark, in this case Fourier transform class B, we can see that it has a predefined size and number of iterations, which is different for each class. You can also see here that we are using the OpenMP version of these benchmarks, and they are using all available logical processors of my CPU. The first benchmark we will be focusing on is FT, the Fourier transform benchmark. We will measure the energy consumption of various classes of this benchmark. I will use perf, as it reports the total time and energy consumed by the benchmark. Let's try measuring the energy consumption of FT class B. Execute the following command: perf stat-e power/energy-pkg/ft.b.x. Let's execute it and wait for results. In my case, the total energy consumed in 7.4 seconds is around 800 joules. Please note that this value is greater than the real energy consumed by the benchmark, because I'm currently recording my screen, which also consumes energy. That's why, when gathering results, I will be measuring energy consumption without recording my screen. So in order to measure energy consumption of several classes programmatically, I've prepared a simple Python script. It executes perf, gets its output, and parses it for each program. Then, it outputs these values in human-readable format. Let's execute this script for various classes of FT. In this case, we will use classes A, B, and C. As you can see, bigger classes take more time and energy. However, power stays relatively the same. Let's repeat our procedure, but for a different benchmark. MG stands for multigrid, and we will also use classes A, B, and C. The results here are very similar to FT, but the average power is smaller. Multigrid, despite using the same processors at full load, consumes less energy per second. In fact, the energy consumption is largely influenced by the program itself. In the case of multigrid, it is very memory intensive, which affects its energy consumption.